Hello everyone. Good afternoon.
Hello, good evening, ma'am.
Good evening. Good evening. Um, should we wait a few more minutes, or I think we should start?
Now it's 7 o'clock.
Yeah, it is 7, so I think we should get started. So, good evening everyone. My name is Malik Arslan Nisar and I am a TA for this course, Numerical Linear Algebra. So, the any one of you wants to summarize what you studied during this week, fourth week?
This week mainly the orthogonal sets were there. Then Graham-Smith
Yeah, Gram-Schmidt
orthogonalization
orthogonalization process, and
and
also
orthogonal bases.
yeah, and
Then
then
introduction to MATLAB was there.
okay, so
Then sign integer representation and computer representation of numbers.
yeah, so yeah, the topics in these weeks were like simple only, I guess. So
Yeah,
you are
that
familiar.
orthogonalization only is slightly
Huh, that is
new.
the only one topic. Others are like fine, right?
Yeah, yeah.
So how many of you have were already like familiar with MATLAB?
Yeah, we are working on that, ma'am.
You are working
We
already
used
in
to work,
MATLAB. Yeah,
but
so
it's a control design like that. I am
okay,
working.
okay, okay, fine.
Not all the toolboxes.
Yeah. So I think we should get started. And so, is my screen visible?
Yeah, and the screen is not. Now it's only coming.
Okay, now it's coming, right? Okay. So I hope my screen is visible. So Gifty, as you mentioned in a previous session that you wanted me to discuss a question on like orthogonal complement.
Yes, yes.
So at
Yeah,
that
yeah,
time, I wasn't sure because I thought you were talking about complement. It's not complement, it's
yeah.
orthogonal complement, right?
Okay, okay.
Okay. So you want to say what an orthogonal complement is?
Yeah.
Yeah, what is an orthogonal complement? I'm asking you. What do you understand by an orthogonal complement?
Okay, if there are set of vectors, then vectors that are perpendicular to that. That is my understanding. That
Yeah, that
dot
is
product will be zero.
yeah. So orthogonal complement. Firstly, I want you to understand that orthogonal and like these terms, these are always in relation to some other. Like it
Yeah,
is not a like independent term. It's like when
yeah.
you're talking about orthogonal, there should be two. Like if you're telling orthogonal vectors, there should be two vectors which are orthogonal. So in vector subspaces, orthogonal complement of a vector space, correct? If there is an vector space, then what we say that orthogonal complement of that vector space is defined um, as a vector space, like another vector space, whose all vectors are orthogonal to any of the given vector subspace. So what does this statement mean? That if you have an vector space, say V, capital V, or I can call it V1, and then I have another vector space V2, I will only say that the vector space 1 is the orthogonal complement of vector space 2 if and only if all the vectors present in V1 are orthogonal to all the vectors in V2. Like if there is V1, V2, V3, and so on, and here we have say A1, A2, A3, so on. So like V1 should be orthogonal to all of them, V2 should be orthogonal to all of them, and so on. Then only these two subspaces are known as orthogonal
Okay.
complement of each other.
So, okay.
So based on this, there was one question
Yeah.
in your assignment, so I thought I should discuss it. So the question was, consider R3 with the standard inner product. Inner product you understand, right?
Yeah. Yeah.
And let W be the subspace of R3 spanned by 1, 0 and minus 1. Then which one of the following which one of the following is a basis for the orthogonal complement of W? So for W, the vector is given that W is a subspace of R3 which is spanned by this vector 1, 0, minus 1. So it is the span of the W. Now the question is asking that among the following options, what is going to be the basis for the orthogonal complement of W? And the options are like 1, 0, 1 and 0, 1, 0, right? Second
Yeah.
option was 1, 2, 1, 0, 1, 1.
One.
The second people are finding. Third option was 2, 1, 2 and 4, 2, 2, 4, 2, 4. Sorry, the fourth option was 2, 1, minus 2, then 1, 3, 1 and minus 1, comma, minus 1, comma, minus 1. So what was the correct option if you have solved this
First
answer?
option.
First option.
First.
And how did you arrive at this answer?
If you take the dot product of 1, 0,
Yeah.
minus 1, this that will be 0. But others, one of the component is not coming to be 0.
Yeah. So it is simple that by the definition of orthogonal complement, all the vectors of W should be orthogonal to all the vectors of given subspaces. So in the following subspaces, when you check, only the first one is going out to be orthogonal to it. Like, how do you check orthogonality? For checking orthogonality, you take dot product of two vectors. A dot B is equal to 0 means A is orthogonal to B, right?
Yes, yes.
So that is how you check it. And if you see, only 1, 0, 1 is going to be orthogonal to this, like 1 into 1, wait a second, plus 0 into 0 plus 1 into minus 1. It is coming out to be 0. And with the second vector, 0 into 1 plus 1 into 0 plus minus, sorry, plus 0 into again minus 1, it is coming out to be 0. For rest of the options, you can check that one of the vectors is not satisfying this condition and the dot product is not 0, so they are not the orthogonal complement to this vector subspace. Correct?
Yeah.
Okay. So since you now have a clear understanding of this, I will give you one question. I want you to solve it. So it is question number 2. Prove that the null space of a matrix A. So prove that the null space of a matrix A, which is M cross N, is orthogonal complement is orthogonal complement to the column space of A. So the question is that given any matrix M cross N, you have to prove that the null space of that matrix is orthogonal complement to the vector column space of that matrix. So you can take your time to prove it. Then we will move to the solution part. So how would you approach this question? Are you guys attempting it?
Just to find null space means A tilde x equal to 0. That.
Yeah, for finding the null space, A tilde x is equal to 0. But here, since the matrix is not given, like an actual matrix is not given, it's for any general matrix you have to prove it.
Yeah.
So how would you do that? Basically, what you have to prove that null space is orthogonal complement to column space. And what was the definition of orthogonal complement? The definition was that every vector in the null space should be orthogonal to every vector in the column space. And for that, you have to prove that every vector in the null space of A is perpendicular or orthogonal to column space, and you have to show that dot product is coming out to be 0.
Yeah.
That is what you have to prove ultimately, that any, if you take any element in the null space, its dot product with any element in the column space of A should be coming out to be 0. If you prove that, it means you have proved this. So anyone who has done this? Okay, look at my screen. Since the null space is not given, let us assume that let U is in the null space of A. We are taking any vector U in the null space of A. So by definition of the null space, AU is going to be 0. Right? That is what the definition of the null space is. That if U is the element of null space, it means AU is equal to 0. And similarly, let V is in the column space of A. What does that mean? That means that if A is a vector and V is in its column space, that A transpose of X is equal to V. Like V is coming out to be the output. Like if any, for any X, if we take A transpose X and it gives us V, it implies that V is the column space, right? You know it from your past lectures. So for, I will write it here, for any X, A transpose X is going out to be V, that is the column space of A. Now, since U is in the null space and V is in the column space, what we have to prove is that U transpose of V, that is U dotted with V, is going out to be, coming out to be 0 or not. If it is 0, then it means that they are orthogonal complement. If it is not 0, then that is not the case. So for finding U transpose V, what we do? U transpose into V, instead of V, we can write A transpose of X. Here, U transpose A transpose can be written as AU transpose, right? And X. But by definition of null space, AU is what? 0, which implies that U transpose V is equal to 0. So, U is orthogonal orthogonal to V. That means every element in the null space, that is U, is orthogonal to every element in the column space, that is V. So hence the null space and the column space of any matrix A are orthogonal complement of each other. Understood? Do I need to repeat anything? So please note this down. Then we will move ahead.
Ma'am, U transpose V equal to 0.
Uh-huh.
Yes. Then U transpose and V is orthogonal to each other. I have
Ah,
a doubt.
when you are taking the dot product of two vectors, one has to be in transpose, na?
Ah,
It's like,
okay, okay, okay.
you understood, na?
Okay, ma'am. Yes, yes, yes. Okay.
It's just for the dot, showing the dot
Ah,
product.
vectors.
Huh.
Dot to each other. Thank you, ma'am. Thank you.
So noted till here.
Yes, yes.
Okay. Now let us move further and uh, this one I have taken from your assignment only. This is the first question. Let V is equal to R3 be an inner product space with inner product summation of I equal to from 1 to 3 x I y I, and let A be a matrix equal to cos theta sin theta 0 minus sin theta cos theta 0 0 0 1, and theta ranges from 0 to pi, and let x is equal to minus 5 0 minus 1 comma 0 belongs to V, then inner product of Ax with itself is. So this is from your assignment only, right? Can anyone confirm?
Yes, yes, yes. That's
Yes. So
question.
how many of you have done it already?
Yes, that option.
Please raise your hands who have done it, and you can put your answers in chat box, whatever you have gotten. Please put your answers in chat box, everyone, if you have attempted this question. Okay, if your answer is 125. Anyone else who got 125 or any other option? What about others? Yeah. Yeah, Sham, what is your query? Okay, you have also done it. So what is your answer? Please put it in chat box. So those who have done it, can you like summarize how you did it? Gifty or Sham?
Yeah, AX, that is that A into X we do, then you have to take the dot product.
Okay, you first multiplied a with x,
X,
then you
then I took the dot product.
okay. So how many of you followed the same procedure for doing it? Others also did it the same way? Okay. So yeah, this is the correct method. But if you have seen in the first lecture, you have been taught some properties of orthogonal matrices, right?
The
Yeah.
yes.
And the one, yeah, first you have to check if it is an orthogonal matrix. If you look closely at A, it is an orthogonal matrix. Why? Because all three columns of it are orthogonal to each other. You multiply cos, like first with the second, it is coming out to be cos theta sine theta minus sine theta cos theta plus 0. And like if you check, this is an orthogonal matrix, correct? So, from the property of orthogonal matrix, what we know that if A is an orthogonal matrix and we multiply it with a vector x, it's not going to change its magnitude, right? You have read it in lecture 1 that an orthogonal matrix, when multiplied with a vector, it's not going to change its magnitude. So, the magnitude of x will remain the same. Now, here, since A is orthogonal, we can simply use this property and we can write that inner product of ax is going to be nothing but inner
X,
product of
dot
x.
X.
Yeah. And if you take the dot product of x, that is going to be 25
25
plus
plus
0
100.
plus I think this one is minus 10 here, right? I have written
Yeah,
it wrong. It is not. Yeah. Let me correct it.
That's a
It
26
is,
as my answer. I'm.
huh?
20, 125.
Yeah, 125 is the correct answer. Like I am also,
25 plus 100.
yeah,
Okay.
so it is coming out to be.
Actually, for this question, I got only 26. That's why I checked.
Okay, okay, okay. So this is how you're going to do it. The way Gifty did it, that is also correct, but that is a lengthy process. What
Yeah.
the purpose of the assignment is that they want you to use the properties also.
Yes,
So the
yes,
property
yes.
of orthogonal matrix, it's not going to change its magnitude. So you can simply do the dot product of x comma x. It would be useful in many situations, like when the A matrix will be huge. That time multiplication with a vector would be like it will be a tedious process. So that time you can use these properties. You should try to remember the properties as well, right?
Yes, yes.
So noted this down.
Yes, ma'am.
So let us move to the next question. Okay. Now, one of the important topics that you have studied is Gram-Smith process, right?
Yes, yes.
So, let us take up a question on that. So, before that, anyone wants to tell what Gram-Smith process is, the procedure, and how it is done? Anyone?
Uh, Actually, Gram-Smith process, which is used for the given bases are linearly independent. From
Uh-huh.
this, you can generate the orthogonal basis and
Uh-huh.
then orthonormal basis. For that purpose only we used to Gram-Smith.
Yeah, correct, Kavita. So, you all know orthogonal vectors are nothing but if I take A and B, simply two vectors, and they are perpendicular to each other, then A dot B is going out to be coming out to be 0. Then we say that these two vectors are orthogonal, right? Now,
Yes.
suppose you are given two vectors like A and another vector is say B. Basically, why we use this Gram-Schmidt process? It is just for creating an orthonormal basis. In you have seen this from childhood that any vector when expressed in the IJK frame, right? In the IJK basis, it is easy because you can easily take the component, the IJK, they are orthogonal to each other, and you can easily break any vector into its components, then you can operate it. So the process gets simpler when you are using an orthogonal basis or an orthonormal basis. Orthonormal is nothing but when orthogonal basis has magnitude 1, they are unit vectors, that time it is orthonormal. So that is why he used Gram-Schmidt process, that given a set of linearly independent vectors, say here A and B, they are linearly independent vectors, but they are not orthogonal to each other. So by using this A and B, if we are able to create a basis which is orthogonal or orthonormal, that is the use of this Gram-Schmidt process. So how we do this? The basic understanding for this is that we consider any vector, like I have taken here two vectors only for the simplification process. There may be many vectors, there might be n vectors, right? So how you perform this, that you fix one vector, say I am fixing B. Now if I take the projection of A on it, correct, this is going to be A perpendicular, and this component of A is going to be the parallel component. And see, this angle is theta, right? So what is the A parallel component? It is going out to be A cos
Constant.
theta. And similarly, the A perpendicular component, it will be what?
A sin theta.
A sin theta. Now look at this A parallel. Can we write this as AB cos theta divided by B? Correct? We can write it as AB cos theta by B. Now it is coming out to be A dot B divided by
B.
B, right? A dot B upon magnitude of B. And then we can represent what? A as A perpendicular plus A parallel, correct? And now A perpendicular, it can be expressed as A minus A parallel, and it can be written as A minus, what is A parallel? A dot B upon magnitude of B. Since I have written magnitude of B here, we can put a B cap as well because it is in the direction of B. Correct. So here you can see that A parallel I expressed already in terms of B, and A perpendicular also I expressed in the terms of B. That is how you create orthogonal vectors. This is just the idea behind it. Now coming to the actual process, uh, suppose, no, let's take example of three vectors. Suppose now we have A1, then we have been given as A2 and A3. How would you solve this problem in the same way? Firstly, you do nothing. Again, what we did here for A and B, you do it for A1 and A2. Correct? And get
Independent of
orthogonal, orthogonal vectors or orthogonal bases. Then in the direction of A3, like in this plane, you take the projection of A3 and calculate the orthogonal vector for this also. And similarly, n dimensional, for n dimensional vectors you can do the same. Here we cannot show n dimensions, obviously we cannot show more than 3 dimensions. So this is basically the idea behind Gram-Schmidt orthogonalization process. Now we will do one question and that will make your understanding more clear about it. So uh, yeah, have you attempted any questions on this
yes, assignment
orthogonalization?
it was there.
An assignment, there was questions, right?
Yeah.
So okay, we will solve one question. Ortho So the question is orthonormalize the set of vectors v1 is equal to 1, 2, 3, 4. v2 is equal to 5, 6, 7, 8. v3 is equal to 9, 8, 1, 6, and v4 is equal to 6, 4, 7. So you have been given four vectors and you have to orthonormalize it. What does orthonormalization mean? You have to first make them orthogonal, then orthonormal. Orthonormal means simply nothing, but you have to divide them
By
by
the
their
magnitude
magnitude
of
to get a unit vector, right?
yes.
So start solving. What would you do first?
First vector is same as the
Orthogonal
V1 only.
vectors.
Yeah, you will fix one vector, say v1. v1 you will take as it is,
First
and
we take
then
orthogonal vectors as u1, u2.
yeah, then you will consider, say you are taking the orthogonal vectors. If you have v1, v2, v3 and v4, say you are converting them to orthogonal vectors u1, u2, orthonormal vectors u3 and u4. So first what we will do, we will take v1 only. So v1 is not going to change, it is going to be 1, 2, 3 and 4. Now what is the magnitude of v1? Do it fast and tell me what you are getting. What is the magnitude of v1 coming out to be?
Root 30.
30.
Root 30,
Root
correct.
30.
Root 30.
Therefore, what is u1? u1 will be nothing but v1 divided by its magnitude, correct? You got
Yes.
v1 vector, then divided by its own magnitude, you are going to get u1 vector, which is the orthonormal vector to the rest vectors you are going to calculate. So 1 over root 30 into 1, 2, 3, 4. So after getting u1, what is the next step? We are going to calculate for
u2.
u2, correct?
Yes, yes.
Yes.
Now anyone who wants to tell what u2 is will be?
V2 minus
v2.
Yeah, wait a second, this is capital u2, okay? So u2 will be what? v2
V2 minus
minus
Minus inner
v2
product
dotted
V
with
with U1
u1
u1.
by
multiplied by
magnitude of
u1, correct?
this
Yes.
Inner product you don't
divided
have
by
to
this
do.
Divided by
magnitude of V
divided by
will come now.
u1, u2.
No, we
Okay.
divide it
Now
with the
you see the orthonormal
yeah,
instead
yeah, it is
already. Okay,
orthonormal.
orthonormal.
So u1 is
Okay.
already a unit vector, so you don't need to divide it with
Okay.
u1 dot u1. That is coming out to be 1 only. So you don't need to
Okay,
divide
okay.
it with
Okay.
that. So what is v2? v2 is 5, 6, 7, 8. Um, others are getting it. Minus 1 by root 30 into what is the dot product of u2 with u1? It is going to be 5 into 1 plus 6 into 2.
7,
See here, 6 into 2, then 7 into 3,
It's 82.
and 8 into
70.
4. This I already took out, so just multiplied these, and then you have to multiply it with u1 vector, right? Wait a second, let me write this again.
Yes.
Here I don't have space. Meanwhile, you can calculate and tell me what you're getting. Just calculate. Yeah. So will be something like 5, 6, 7, 8 minus 1 over root 30 into dot product of these two multiplied with this u1 vector. And what is that? 1, 2, 3, 4 into 1 by root 30. Correct? What are you getting out
Yes.
of this? It will be 5, 6, 7, 8 minus 1 by 30 into 5 plus 12 plus 7, 21 plus 32 and multiplied by 1, 2, 3, 4. Are you guys solving along with me?
Yes.
Yes.
Yeah, so if you arrive at the
So
answer,
final answer
yeah, what is the
8
final
by
answer?
3,
8 by 3, yeah.
4 by 3,
Mm-hmm.
0. Oh,
Yes.
sorry. Comment.
And what is the last element?
Minus 8 by 3.
Yeah. So you have calculated correctly. It is coming out to be 8 by 3. This one will be 4 by 3, 0 and minus 4 by 3. What about other
Minus
people?
8 by 3.
Got my.
Last one is minus 8 by 3.
Last one is minus 8 by 3. No, I think you have made some mistake. Wait, let me check it.
Okay.
I have to wait a second, check it. 8
Ah,
minus.
okay, okay. Myself mistake.
Ha. Anna, it will be minus 4 by 3.
Mm. Minus 4 by 3.
Yeah.
Myself mistake.
So others got this? You
Yes,
too?
yes.
Now, U2 is not orthonormal, right? It is not orthonormal to U1. So it is orthogonal. So we will divide it with its magnitude again to get, I'm writing this as small. This is small U2. How will you get it? Divide U2 by its magnitude. Correct? So that is coming out to be root 3 upon root 32. Calculate this fast and tell me what you are getting. This is nothing, you just have to use calculator. It's simple calculation. So this will be root 3 by 4 root 2, 8 by 3, 4 by 3, 0 minus 4 by 3. What is this coming out to be? Calculate and tell me the value.
4 by 3.
4 by
4
3.
by 3 root 6. 4 by 3 root 6.
It's not 4 by 3 root 6. It will be root 6 by 3 only. 4 is not there. You're making some mistake. Check it.
Hmm. Okay, ma'am.
Yeah. Anyone else? See, you will simply take it inside. It is root 3 by 4 root 2 into 8 by root 3. The second one will be root 3 upon 4 root 2 multiplied by 4 by 3. Third one will be 0, and fourth one will be root 3 upon 4 root 2 multiplied with minus 4 by 3. 4 1 4 2, and it will be what? Here we have 3, here we have root 3. It will be root 3 into root 2 divided by 3. Correct? It will be root 3 divided by 3 root 2. This one will be 0 and this one will be minus root 3 divided by 3 root 2. Check if I have done it correct or not. You are getting the same? Now this will be root 3 into root 2 is root 6 by 3. Then it will be 1 by root 6. Correct? Third will be 0. And last one will be minus 1 by root 6. Did you get the same answer? Can anyone confirm? Are we on the same page till now? Okay guys, you check it. I'll give it you a moment. Take a minute and tell me what you are getting. Kavita Gifty, did you solve it?
Yeah, actually, it's the same answer I'm not getting. I'll try it also.
Oh, you're not getting same answer.
Yeah, no. Yeah.
Fine, you might be making some calculation mistake. No. So
Yeah.
you check it at your own end, but this is the correct answer.
Yeah.
Root 6 by 3, 1 by root 6, 0 and minus 1 by root 6. Now I want you to proceed with this u2. है ना? Take this u2 and now we will calculate what? u3. So help me complete. What is u3 going to be? v3
C3
minus v3 dotted with u1.
by
Again denominator we don't need to write it. Then minus what? v3 dotted with u2
u2
multiplied with u2. So again this is going to be what? 9 8 1 6. Solve along with me. This is going to be 1 over root 30. Then 9 into 1 plus 8 into 2 plus 1 into 3 plus 6 into 4. Then 1 over root 30 and u1. That is 1, 2, 3, 4. Then minus 9 into root 6 by 3 plus 8 into 1 over root 6, taking the dot product of v3 with u2. So that will be this. Here we have v3 and u2 we calculated in last step. So just taking the dot product, this will be 1 into 0 and plus 6 into minus 1 over root 6, and then multiplied with u2 vector itself. That is what? Root 6 by 3, 1 by root 6, 0 and minus 1 by root 6. Written till here? Did you guys write till here? Now, what is this going to be? 9816 minus, it will be 56 by 30 into 1, 2, 3, 4, then minus 3 root 6 plus 8 by root 6 minus root 6 into root 6 by 3, 1 over root 6, 0 and minus 1 over root 6. Are you guys solving it?
Yes, now it is 56.
It is 50, no, sorry, it is coming out to be 52 by 30. Yeah.
Yes, 52.
Yeah, it is 52 by 30 here, sorry. 52 by 30 it will be here. Then 9816. If you are getting the answer, you can tell me if you have arrived at the answer. Then this will be what? It's 30 and 52, 15 will be 26. So multiplying it will be 26 by 15. There will be 52 by 15 again. 26 by 15. So 26 by 15 into 3, that will be 26 by 5 and 104 by 5. 15 minus, this will be 2 root 6, plus 8 by root 6 into root 6 by 3, 1 over root 6, 0 minus 1 by root 6. And from here it will be 9810 minus 26 by 15, 52 by 15, 26 by 15, sorry, 26 by 5, and then 104 by 15. So, and here it will be minus, it will be 20 by root 6 and multiplied with this vector again. So guys, calculate this and tell me what you are getting. From here calculation is easy. Use your calculators and tell me what you are getting. Is every one of you solving? This is a lengthy process, but like this is how you have to do it. So anyone got the value of u3? Kavita?
First one is 9 by 15.
9 by 15, yeah. That is 3 by 5, huh?
3 by 5. Next 18 by 15.
Huh?
That is 6 by 5.
Yeah.
Minus 21 by 5.
Huh?
The last one I did not.
Last one is what? Okay, still you're doing it, huh?
I'm still doing.
Yeah, yeah. What about others?
Minus 4 by 15.
Minus 4 by 15. No, I think here you are making some mistake.
No.
Check it again. This one is not going to be
Minus 1.
minus. Anyone else who did it apart from Kavita? Guys, you should solve it here, huh? That is the purpose of this session. Otherwise, I will write on my own pace and you will be like sitting and watching. That way, you will not understand
Minus
things.
18 by 5.
18 by 5, I think
Minus 18.
you are making some mistake. It's 12 by 5. But if you are sure, then I will check it once. If I have made some mistake, 6 minus my calculator and check it again. Yeah, this will be 12 by 5 only. So you guys check it once at your own end because like there might be some
It's done.
calculation error. Yeah, 12 by 5 is right now.
Okay, mom. We
Huh?
check it later. Okay, mom. We check it later, mom.
Okay. So what is the magnitude of U3 from here? Come on, do it fast. It will be 3 by 5 square plus 6 by 5 square plus minus 21 by 5 square plus 12 by 5 square. It will be 126 by 5. Therefore, U3 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 will be what? U3 divided by magnitude of U3, right? So calculate it fast and tell me what you are getting. What will the first element be?
One by root 70.
Yeah, 1 by root 70. The second it will be root 70
70 by 35.
by 35. The third one will be minus root 70 by 10 and 2 root 70 by 35. You can check if I am wrong. You can verify the answer on your own also. Has everyone reached till here? Should we move further now for calculating U4? Noted till here? Okay, let me wait a minute and then we will calculate U4. Should we move further for calculating U4?
Okay.
Okay, noted now everyone. So now for U4, what will U4 be? It will be nothing but V4 minus V4 dotted with U1 minus V4 dotted with U2 and minus V4 dotted with U3. So if you notice, it is nothing but a pattern is following, that if you have to calculate un, it will be nothing but vn minus vn dotted with u1 into u1 minus vn dotted with u2 multiplied with u2, then vn dotted with u3 multiplied with u3, so on up to up to vn minus 1, right? That is the pattern you follow in Gram-Smith process. Now I want you to do it quickly on your own, and this time I am expecting that you will do it correctly. First step I am writing out for you: 6 4 7 2. Then you will subtract it from 1 over root 30. Then dot product of u4 with u1 is going to be nothing but 6 into 1 plus 4 into 2, then 7 into, what is the third element of u1? 3 plus 2 into 4, then again multiplied with magnitude of then again multiplied with the u1 vector, and then same with u4 dotted with u2 is nothing but 6 into root 6 by 3 plus 4 into 1 over root 6 plus 0 minus 2 into 1 over root 6, then multiplied with u2 vector, which is nothing but root 6 by 3, 1 over root 6, 0 and minus 1 over root 6. Then 6 divided by root 70 plus 4 root 70 divided by 35 minus 7 root 70 divided by 10 plus 4 root 70 divided by 10, not divided by 10, it will be divided by 35 here, and then multiplied with u3 vector again, which is nothing but 1 over root 70 root 70 by 35, then minus root 70 by 10, and 2 root 70 by 35. So guys, calculate this and tell me what you are getting. Clearly. I am writing this again here. Meanwhile, you calculate and tell me what you are getting. Root 70 by 35 minus root 70 by 10 and 2 root 70 by 35. Anyone calculated? We can take 3 more minutes. Then you have noted the whole expression, na? Anyone? Not yet. Okay, at least you can calculate the first element to see if you're doing it right. Tell me what the first element of U4 will be. So you can check it, I think, later. For your reference, I will tell you what the value of U4 is going to be. It will be 2 by 7. Please note this down. Minus 3 by 7, 0 and 1 by 7. This is what the value of U4 will be. So later on you can like practice this question one more time at your own end. But for the time's sake, we will like proceed further now. So the magnitude of U4 is going to be here, if you calculate, it will be under root of 2 by 7, and thus we get the U4 vector, that is U4 divided by magnitude of U4, which is nothing but root 7 by 2 into 2 by 7 minus 3 by 7, 0 and 1 by 7, and this will be equal to under root of 14 by 7 minus 3 root 14 by 14, 0, and the last element will be under root of 14 by 14. So this U1, U2, U3 and U4, which we calculated right now, these are going to be the orthonormal vectors which the question was asking for, and the procedure you followed, it was Gram-Schmidt orthogonalization process. Fine. Any doubt in this question? Apart from the calculation mistakes like that, you can check at your own end again, because I have provided you with the final answer. Other than that, any doubt in this question or the process? Then I can explain it. So should we move further if you have no doubts?
Okay. Okay.
Okay. Now there is one more question on the same process, but this is an important topic. But I think first we will do some small questions on decimal system, so that you also don't get bored, right? Or should we do the another question also on this process only? Okay, let's do some simple questions. So you have studied the decimal systems, like other number systems. Can anyone summarize what all systems were discussed? Anyone?
Binary, then hexa, X and octal.
Hexadecimal,
So
binary,
that's, yeah. Three systems addition to decimals were discussed.
there was octal system, there was hexadecimal system, there was binary
Binary
system,
system, yeah.
and the another one was the normal decimal system.
Yeah.
So anyone else who wants to like tell the difference between the systems, or maybe Gifty if you want to?
Yeah, actually, this decimal system works on the base of 10. We have 9 numerals. Coming to binary, we have only 2 numerals, 0 and 1. And if you go for hexadecimal, it will be 16. 0 to 15 will be there. And octo, it is 0 to 7.
Yeah, and in hexadecimal,
Zero
from
to-
10 there will be not numerals, but they will be digits, right?
A, B, C, D.
Alphabet.
Yeah, they will be alphabets.
Yeah,
So,
that's
okay, then we will do some small questions on this. Uh, Convergence you also have read. So,
convergence.
the conversion from one system to
Convert,
another.
yeah.
Yeah. So, convert 159 in the decimal system to octal system. Decimal system is nothing but basically the system which we use, which has 10 digits. It's maybe because we humans have 10 fingers, and we used to, like, for assessing it, we gave the decimal system as the 10 digits. And the binary language, it is the language of computer, and in computer the input is always like the digital way, either it's on or it's off, either it's true or it's false. So there only two digits are useful, that is 1 and 0. That is why binary has two digits only, because computer process it that way only. And in the decimal it is 10 digits. And in the octal system we have 8 digits, as Gifty said, from 0 to 7. And in hexadecimal we have 16 digits. And there is one thing in octal system, a few more important points are that each octal system, in octal system, each digit is equivalent to 3 bits. Like, if you take 3 bits in binary, that is equivalent to one octal system digit. And if you take 4 digits in binary, that will be equivalent to one digit in hexadecimal system. So these are some important points you would have learned it through the lectures. Now convert 159 in the decimal system to octal system. So how you do it?
Divide by 8.
Yeah, you
Cut
divide it by
the
8
remainders.
and get the
Add
answer.
the
Tell me what you are getting.
remainders.
It will be 159 divided by 8. So that is 8 ones
1.
are 8 twos are 16, right?
1.
Uh,
1. 1.
yeah, wait a second. It will be 8 1. Sorry, 16 is bigger than 15. It will be 8 1. Then it will be
Remainder is 7.
9, and remainder is 17. Sorry, 7. Then 8 2, and here the remainder will be 3. 8 twos are 16, and remainder will be 3. Then again by 8. Yeah, Shinchan, you are right. So, okay.
No.
Then 8 0, 8 0, and remainder will be 2. So 2 7, uh, 237 you will be getting, right?
Yeah.
So 159 in the decimal system is equivalent to 237 in the octal system. So another question is convert 380 in decimal system to hexadecimal system. How will you do this? It will be divided by which number?
2.
16. It's hexadecimal.
Yeah, 16. Yes.
In binary you divide by 2. In hexadecimal you will
Yes.
divide it by 16, and the process will remain same. So quickly do it and tell me what you are getting. So this will be nothing but 16 into 2, 3. Here you will get 0. Then 16 into 1 is 16, and the remainder will be 7. Then again 16 into 0, and the remainder will be 1.
First
Here,
one
here,
reminder,
here, 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 here.
Oh,
Sorry.
16.
Wait a second, I made a
reminder
mistake.
32.
Yeah,
of 12.
yeah. Will it be 23 or 16? No,
30.
16 twos are 32, and 5 16 twos are, oh, remainder will be 12. Correct?
Hmm.
So, and it was 7.
17B.
17C.
Huh. So now look clearly, it is 1, 7, and here it is 12. But we know that in hexadecimal system, 12 represents
C.
A. Sorry, C.
C.
12
C.
represents C.
C.
Yeah. So that is why we will write it as 17C in hexadecimal system. So 380 in decimal system is equivalent to 17C in hexadecimal system. Correct? Now the third is binary. So one question we'll do on binary. Convert 18 in decimal system to binary and tell me what you are getting. In binary, you will do the same process but repeat it with 2, right?
Yeah.
So it will be 2 9 and the remainder will be 0. Then it will be 2 4. 2 fours are 8 and 1 will be the remainder. Then 2 twos are 4 and 0 will be the remainder. Then 2 1 and here 0 will be the remainder. Then 2 0 and 1 will be the remainder.
One
Yeah,
zero
Sachin, you
zero
are
one
get
zero.
correct. The answer is 10010. So 18 in decimal system is equivalent to 10010 in binary system. Correct. Now let's do some one more question. 1100 for the back conversions also. So this is a number you have given in decimal, sorry, binary system. Right now we did problems for converting numbers in decimal system to octa, hexagonal system and binary system. Now you have given a number in binary system and you have to calculate it, calculate this in decimal system. So do it fast and tell me what you are getting. How will you do this question? Anyone? Can anyone tell
It
her
is,
how?
it is a first numeral into 2 power 0 like that.
Yeah.
You have to do.
Like we divided in the previous questions, here what we
Multiply.
have to do, we have to take the, it's obviously the reverse process. There you divided by 2 and here you have to raise every every digit with the power at which it is standing. Like I will explain it. 1 is at zero's place, so you will keep it as 2 into 0 into 1. Then here it is again 1, then you will put 1 into 2 to the power 1. Then this digit will be 0 into 2 square. Then this is a third place, so it will be 1 into 2 cube. Then this one will be again 0, then 0. Then it will be 1 and 2 to the power 4, 5, 6 into 1. And this one will be 2 to the power 7 into 1, right? So that is how you do it. Calculate and tell me what you are getting. It will be 1 plus 2 plus 64 and 128. It will be,
It's 2 or 3.
huh? Okay. So yeah, 203 you are getting here in decimal system. Correct? Everyone got this? Now I will give you something in hexadecimal system 2C4. Tell me what is it is decimal part. It is in hexadecimal, convert it to decimal. How will you do it?
Splitting.
Again, you have to multiply with the powers of 16. So here you have 4 into 16 to the power 0. Then C stands for what? 12,
12.
right? So you
12.
take 12 into 16 to the power 1. Then 2 is 2. 2 is simply 2 and 16 to the power 2. So what is this going out to be? It will be 2 into 2, 56 plus 12 into 16 plus 4. Tell me quickly what is this number?
708.
It will be 512, then plus 192, then plus 4. It is going out to be 708. Right? So 2C4 2C4 in hexadecimal will be 708 in decimal. Okay, now last question from octal system. Convert 672 in octal system to decimal system quickly. Then we will do another question on Gram-Smith process and we will end the session.
Four 42.
Yeah, 442 is the correct answer. Here also you will do nothing but 2 into 8 to the power 0 plus 7 into 8 to the power 1 plus 6 into 8 to the power 2. Will be 6 into 64 plus 7 into 8 is 56 plus 2. So when you calculate this, it is 384 plus 56 plus 2. That will be what? 10, 12, 702, right? No, sorry. Okay, it will be 12 and 13, 14 and yeah, 442. 442 in the decimal system. Everyone got the same answer?
Yes.
Okay. So now we will do one more question on Gram-Smith process. Then we will end the session. So mm, the question is, let V is equal to R3 be an inner product space with inner product equal to summation of I running from 1 to 3 xi yi and let S is equal to u1 u2 u3 where u1 is equal to 1 comma minus 1 comma 1, u2 is equal to 1 comma minus 1 comma 1 and u3 is equal to 1 comma 1 comma minus 1. I think this is the question from your assignment, right?
Assignment side difference is there, madam. That U1 is minus 1, 1, 1. That
Okay, u1 is different, minus 1, 1
minus
and
1,
1.
1.
Okay, this is slightly different then. Or
Yeah.
maybe while noting down, I wrote it wrong in incorrect way. Then ortho. But if you understand this question, you can solve that one also, right?
Yeah.
Basis of V. Then the orthonormal basis of V derived from S is. Wait a second, let me check the question first.
The question is wrong, I think, because you and you two both are same
U1 and U2
dependence,
are same.
same.
So that
So
is
dependent.
that won't be a wrong question, but yeah, U1 U2 can be same.
Dependent.
Huh?
Then the basis, the elements are
Then the
dependent,
basis will come
linearly
out to be
dependent.
zero. When what will happen in this condition is that while calculating V2, you might get 0. And in that case, because they are the same vector, in that case you have to choose that vector arbitrarily, because there are cases in some questions, like here it is evident, but in some questions there will be two vectors which will be along the same line, and when you take their dot product, that will be 0. And at that time, if it comes out to be 0, you have to choose that vector, like yourself only. I will show you during the question, but for now you keep this question as it is, and if you have a similar question in your assignment, it will help in that. Okay.
Okay, ma'am, but my question is,
Uh-huh.
Gram-Schmidt process only useful when the elements, basis elements are linearly independent.
Yeah, yeah, it
But
uses
here
linear.
U1, U2, it is linearly dependent.
It's
Uh-huh.
Then
the
how can
same.
we use
So,
Gram-Schmidt?
Hmm. I think, yeah, then maybe because I took this question from some assignment only, and I don't know that why there it was written like this only. Wait a second. Hmm. Minus one, one and one. In your assignment, what is it given as?
U1 is minus 1, 1, 1.
Okay, it is minus one.
1,
The
1,
second one is one, and the third one is also
1.
one. And what is the second vector? It is one, minus one,
Same.
one,
1.
and the third one is this.
1,
Okay,
1 minus 1.
okay, here I will have to give extra effort because I have not solved for this question, but let's try this. What is the first vector again? Minus 1,
It's 1, 1, 1 by
minus
root
1,
3.
1 and 1, right?
Yeah.
Okay, so these are the three vectors. So we can fix one vector, right? U1 is equal to V1, and that will be equal to
Minus
minus
1,
1, 1
1,
and 1.
1 by
Now
root
calculating the magnitude, yeah.
it's root 3.
The magnitude is root 3.
Yeah.
So V1 will be the U1. Wait a second. Huh. So U1 is equal to, sorry, V1 is equal to U1 divided by magnitude of U1, and that is equal to 1 over root 3 divided by 1 over root 3 into minus 1, 1 and 1, right? So this is going to be nothing but 1 over root 3 minus 1 over root 3, 1 over root 3 and 1 over root 3, correct? Now, what will be the v2 vector? Anyone? v2 will be u2. Guys, if you are speaking, you are not audible. Hello?
Yes, you're audible.
Okay, okay. So, what is v2 vector? It is u2 minus u2 dotted with. Is my screen visible or it is gone?
The screen is not visible.
Okay, okay. Wait a second. Let me do it
Screen.
again. Is my screen visible now?
Yeah. Yeah.
Okay. So, what will be v2? v2 will be nothing but u2 dotted with v1
V1
multiplied with v1.
into
So, here u2 is 1,
stuck up or something.
1 minus 1, 1 minus what is u2 dot v1?
Hello?
Hello? Uh-huh. I think there is some issue with my internet. Hello?
What's that?
Back. Madam Joy.
Yeah.
Okay,
Actually, there is some internet connection issue from my side. Sorry
Okay.
for that. I don't know, it's the college Wi-Fi only. Uh,
No
wait
problem.
a second. Is my screen visible?
No. Yeah, now it's
No.
coming.
Okay, okay. So yes, I was telling that, now U2 will be what? Sorry, V2 will be what? It will be U2 minus
2
U2
minus
dotted with
U
V1 into V1.
and V1.
So U2 is 1 minus 1 and 1.
1 minus
Huh,
minus of 1 by 3
huh. Wait a second.
minus 1 1 1.
So this will be minus 1 by root 3, correct? Then
Yeah.
it will be minus 1 by root 3, and this one will be plus 1 by root 3 into minus
Minus 1
1 by
1 and 1.
root 3.
Minus 1 by
Huh, 1 by root 3 and 1 by root 3. So,
finally it will be
uh, I don't know why everything is going wrong today. Wait a second.
yeah, just 2 by 3 minus 2 by 3 4 by 2.
So, wait a second. Yeah. This you are getting as what? This will
2
be
by
cancelled. Then it will be 1 minus 1 1, and this will be plus, and 1 by root 3
1
multiplied
3
by 1 by root 3 will be what?
1 by 3
1 by 3. This will
into
be
minus
minus 1 by
1
3, correct? And this one will be 1 by 3, minus 1 by 3, correct?
no, no, minus 1 by 3 1 by 3 1 by 3.
These two got
No,
cancelled. It will become plus here. Now it is 1 by root 3, na? Okay, yeah, sorry.
no, no.
Wait a second.
Yeah.
This one will be
Minus
minus and these two will be
yeah.
plus, right?
Yes, 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 yes.
Now what is this coming out to be? It will be
2
2
by
by
3 minus 2 by 3
minus 2
4
by
by
3
3
and
4 by 3.
4 by 3. So this is our first vector.
Yeah.
Now, sorry, this is our
Normalize
second vector, V2. Now we will divide this with its magnitude, right?
2 root 6 by 3.
Okay. The magnitude is coming out to be
2 root 6
2 root
root
6
6 by
by
3.
3.
Yeah.
And now what will be the V2 vector?
1 by
1
root
over
6
1 by
minus
root 6.
minus 1 by root 6.
Okay, you're telling the final answer, right?
Yeah. Yeah.
Minus 1 by root 6, and third one
2
is
by root 2 by root 6.
2 by root 6.
Yeah.
Everyone is getting the same because I am not checking it, na?
Yes,
I
yes,
have
correct, ma'am. We too get
Okay.
the same.
You also got the same, right? Now V1
Yes,
you
ma'am.
have gotten, V2 you have gotten, now V3, right?
Yeah.
So how you will calculate V3? I'll write the
U3
formula.
minus
U3
minus
minus
U3
U3
dot
dotted with
V1
V1 into V1,
V1
then
minus
minus U3 dotted with
U3
V2
V3 into E2.
multiplied with U2.
U2.
So this is going to be what? What is U3?
1
Quickly.
1 by
one
root.
U3 is
minus
1,
1
1
1
minus 1.
minus 1 plus 1 by
Huh.
3.
What you are getting this? This whole you have calculated?
Yeah.
U3 dotted with V1 into V1. Tell me what you are getting the value of this.
1 by 3 into minus 1 1
1 by 3,
Minus 1 by 3.
minus 1 by
Sorry, minus
3 1 by 3 1 by 3.
minus 1 by 3, second is 1 by 3, and third is 1 by 3.
That is U3 plus now.
No,
First
no.
into plus.
First one is plus and rest two are minus.
No, the
yes.
minus. Yeah. No,
Uh,
madam. No, actually this 1 1 minus 1 plus then minus 1 by.
okay, you're telling me that this is 1, 1 minus 1. Now here we have a minus sign. So
Yeah.
what is this coming out to be? U3 dotted with V1 into V1. Have you
Then
calculated
1
this?
by 3 minus 1 by 3
1 by 3
minus
Minus 1 by 3,
1
and
by
the
3
third one is
1 minus 1 by 3.
minus 1
minus
by
1 by
3.
3. Okay,
Yeah.
correct. Now third one,
1 by
U3 dotted with V2
plus 1
multiplied
by
with V2.
yeah plus 1 by 2 into
Minus
2
1
by
by 3
Minus 1 by 3
plus 1 by 3
3
plus 1 by 3
minus 4 by 3.
minus 2 by 3.
Minus 2 by 3. I think you are having a
Yes.
conflict. Are you getting the same Gifty?
Yes, yes.
The same answers, right?
Yeah, yeah.
Yes.
So subtracting all these three, what you are getting?
Finally, 0, 1, 0. Sorry, 1, 1, 0 we'll get. 1,
Okay.
1, 0.
1 by
1,
root
1,
2.
0.
These
1
two
by
will
root 2.
cancel each other. It will be 1. Second one will be
1, 0.
the
1
first one
0.
is 1. The second one is 1.
1 and 0.
The
1
last one is 0.
0.
Right?
Yeah. Yeah.
Yes, yes,
Okay.
ma'am.
Now this is the
And normalized will be 1 by root
huh,
2.
the norm. This is the U3. Okay, small U3 can write. Now normalizing it, what we have to do, we have to divide by its magnitude, that is 1 by
Root, root.
root 2.
Root 2.
We will divide it with its magnitude to get the normalized vector. That will be 1 by root 2, 1 by root 2 and 0. So these
0.
are the three vectors you are getting, right? So is
Yeah.
there a option corresponding to the same?
Yes, first options.
Yeah, the first option will be there. So for now, this much we will do, okay?
Okay.
Because there is some internet issue also on my side, and I thought these much questions will be enough, so I haven't any more questions. But yeah, we can take one more from the binary that is in your assignment only. Have you calculated that? Minus 56 in decimal system, it's binary representation or sign integer representation, what we call as.
This 1, 0, 1, 1, 1, 0, 0, 0.
Yeah, how would you calculate that? Firstly, for the minus sign, you
Yeah,
will assign
minus
a
56 we will divide, that will be 1. The side integer will be
huh,
1.
yeah. And for 56, again, you will repeat the
It means 0, 1,
same
1, 1.
process.
Yeah.
It will be 0, 2 ones are 2 fours are 0, 2 sevens are 14, and it will be 0. Then it will be 2 threes are 6, and remainder will be 1. 2 ones are and remainder will be 1, and 2 0 and remainder will be 1. Something like that.
Yeah.
And that is 1, and
0,
here will put be a 0, 1 1 1
1, 0, 0, 0.
0 0 0 in binary representation. Fine.
Yeah.
So, okay, we will end today's class here. So, is there any topic other than like in during the week which we haven't discussed, or you want a question on that?
Any other working exercise you have, madam, other than the assignments for exam and all?
For the exams, any other questions, right?
To work
Like,
out and come. So, actually, this much question, means I don't know how the exam will be, but this type of questions will come means it will be very difficult now. This
yeah,
graph
if these
sheet.
no, the type of question I am giving is just for the understanding. I know they are a bit lengthy, or
Yeah.
sometimes they use one or two concepts. I don't think in exams they will ask you that level,
Ah,
but like they will be at least solvable during the class only. They will
oh,
ask you that questions only. I am not sure about how the NEPTIL paper is, but have you access to the previous year papers?
no, no, I haven't.
I think you should collect previous year papers from somewhere.
That
If I
that's
get
who will have anybody any site or something. It is there because we are all remote students. No, we don't have access with anybody else.
okay, okay, I will try to get like I will try to find the previous year questions because we don't
Okay,
have access to them. But if I get them, I will share them with you.
okay,
Okay.
okay, okay, ma'am.
When is the exam
Okay.
going to be for this
That
one?
is April, madam. April 28th.
Okay.
April 28.
8.
Okay, in April, no? Okay, I will try to get some questions which are like on the same pattern. I will try to figure out previous year papers.
Actually,
Fine.
I want to know the pattern, ma'am. It is a multiple choice question or some
Okay, well,
descriptive
MCQ
manner.
only they told.
I am not sure about it, so I will not tell you anything
Ah,
right now. I will confirm it, but okay.
okay.
Okay,
Okay.
I will confirm it and I will let you know what type of questions they're asking. But if they are giving you MCQs and assignments, I think in the final exam also they will be giving assignments. The final exam will be
MCQ
of
only, but the time, the 3 hour means there's a limitation which we can solve. No?
हाँ
This type
exactly.
of
Okay, I will confirm it from somewhere. I will let you know. Okay.
Okay.
Okay. Okay.
Okay.
Then goodbye. Goodbye.
Okay. Next week, same day, it will be
Next week, I don't think I will be able to take because my midsem exam is starting from Monday, and it will continue to till Saturday. So I will probably take the next session on Sunday, but
okay.
you will be informed about that.
Yeah, okay, okay.
Okay. Okay.
Okay.
Okay. Okay.
आप जिस व्यक्ति को कॉल कर रहे हैं वह उत्तर नहीं दे रहे हैं। कृपया कुछ समय पश्चात प्रयास करें।